Here in this diagram, you can observe this is a cylindrical vessel whose diameter and height both are equal and equal to 30 centimeter. You can follow the diagram. And there is a point P which is located at a distance 5 centimeter from the center of the base. Okay? And we are observing through this slit. You can observe we are observing through this slit at this corner. And if there is no water in the vessel, the direction of the light ray is like this. That is, we are observing the corner of this vessel and our requirement to observe point P, right? So the question is, up to what minimum height water should be poured into the vessel? Up to what height the water should be poured so the point P can be visible? If you follow the diagram here, you know the height of the vessel and base diameter is equal. That means this line should incline at angle 45 degree with the vertical, because this is a right angle triangle. If you follow the path of my pen tip, this angle should be 45 degree. And if we want to observe point P, the angle of inclination of the refracted ray should be less than 45 degree. That means the path of the light ray inside the water should be like this. Suppose this is the water depth and the light is traveling from this point and reaching to this point. You know, after coming out from the water, the light again travel at angle 45 degree with the water, and inside the water the angle of inclination of the light ray with the vertical is less than 45 degree. So here we can say this should be the path of the light ray, correct? And let us use the geometry first. Let us make point AB, and you can observe this is a right angle triangle, and the depth of the water is h, and this angle is 45 degree. And if this angle is 45 degree, we know this length AB is again h, because h is the depth of the water. So if this is h and this angle is 45 degree, that means this length should be h. Okay? And we know diameter of the vessel is 30 centimeter. That means this distance from here to this point is 15 centimeter, and this is 5 centimeter. That means this length is 10 centimeter, and here we can write this length, that is distance between P and B, is h minus 10, because this distance is h and this is 10 centimeter. That means the distance from this point to this point is h minus 10. Now we can observe there is a right angle triangle. This angle is theta and this is the right angle triangle. That is APB is a right angle triangle. And we can use Snell law at this point. If this angle is 45 degree, this angle is theta, we can write here 1 multiplied by sine 45 equal to 4 by 3 multiplied by sine theta. Now sine theta equal to 1 by root 2. In this way we can get the value of sine theta, and sine theta is equal to 3 divided by 4 root 2. And as we discussed, this APB is a right angle triangle. Now we can use simple trigonometry to get the value of theta. Now let us place this diagram again. You can write simple trigonometry term, that is tan theta equal to PB divided by AB. And we know the value of sine theta. From this sine theta value, we can get the value of tan theta. We can write tan theta equal to, this is 3 divided by 4 root 2 square minus 3 square. 3 divided by 4 root 2 square minus 3 square. After solving, we get the value of tan theta equal to 3 divided by root 23. Correct? Now we got the value of tan theta from this Snell law notation. Now we can write PB equal to h minus 10 and this AB equal to h. So this tan theta equal to h minus 10 divided by h. Correct? Now we can equate the value of tan theta which we have calculated here and tan theta which we have calculated here. Let us equate these two values like this, and we know here value h is only unknown. We can calculate the value of h from this relation. Let us cross multiply relation and rearrange the value of h, and we'll get the value of h like this. That is h equal to 10 root 23 divided by root 23 minus 3 centimeter.